With Swiss punctuality, we're going to start with this session today. So my name is Jose Castro. I'm the technical leader for the Cloud Infrastructure Service at CERN, and he's my colleague.
Hello, everyone. My name is Luis, Senior Cloud Engineer, OpenStack Operator, working with Jose.
Basically, this talk is mainly for operators and try to share our experiences of running our cloud since 2013. But first, as a start, we're going to talk about what we do. And basically, what we do is we are the biggest, so the largest particle physics lab in the world. Has been founded in 1954 with 25 member states. And what we do is fundamental research in physics. Basically, we collide particles. We analyze the data that comes from it, and we store it for further research. From a bottle of hydrogen that we ionize, we go through the whole history of accelerators at CERN, from the booster to the proton synchrotron to the SPS, and then finally to LHC. And you may know the 4 experiments in which we are colliding particles. But those data that comes from the experiments, it goes to us, the IT department. We are taking care of the transmission of the information that comes to the data center, to store it into tape for longer periods, to analyze later, and then also to host the facilities that analyze the data later on. And those facilities are managed under an OpenStack cloud. And this is where we come in. So we have an infrastructure as a service set up in July 2013 that we are carrying over since then. We are operating it in place, and it's based in the Red Hat distribution OpenStack, RDO, and we are currently running all our hypervisors under Red Hat Enterprise Linux 9 and Alma Linux 9. We have two data centers, one that was started in 2013, another one that we put online in 2024, and we offer a vast majority of kind of resources to the whole lab. Computational resources, like the physical servers, VMs, or container clusters. We have also storage that you may know, like images, volumes, file shares, and object store that people can use for their applications. And we also offer network equipment, access to network equipment, like load balancers and private networks. And we use all the facilities we can have at hand for those, like the heterogeneous architectures, like x86, that is vast majority, but we also have ARM resources, GPUs, and other kinds of accelerators. We could look at the stats. This is a kind of a picture from like 2 weeks ago. We have around 10,000 physical servers managed in the infra, around 15,000 virtual machines that are that are basically our main users. We are managing 1.65 petabytes of memory on the setup, 300,000 cores, and you can see on this chart the availability of both data centers, because we are constantly probing the site to ensure that our users can create machines pretty much all the time. As I said, we upgraded the setup in place since 2013. So if you have a machine back then, it's still running. And what we started on is Scientific Linux and Grizzly. And we have been doing upgrades in place of that setup for 4 major releases of the OS and almost 25 releases of OpenStack. We also started with Nova Network, which we finalized the migration to Neutron in 2023. And we are currently doing a transition from the Linux Bridge ML2 driver of Neutron to OVN. We are more or less at 35%. The last 3 years of the setup, we were basically catching up because we were a bit behind in terms of versions. As you can see there in the slides, we were in 2023, we have scattered the services with different releases, and we did a major effort to align to the Joker release. That is what happened in 2024. And our main DNA when we came with the OpenStack community was to contribute back to the community. And basically, we were deploying the services in not being falling behind like 1 or 2 releases from the upstream community, being on a maintained version so we can contribute back to the OpenStack family. And basically, the objective that we have for this year is that on this green side, that is aligning every single component to epoxy, where we have the most majority there. And then we have the last 2 that will come up at the end of the year. There is Neutron and Nova that will come up in Caracal. But all this effort that we did, it doesn't come with kind of nightmares at night when things go wrong. And they are kind of something that is basically the main topic for the talk today, is something that could happen with the physical hardware, for example. So sometimes it's like, and it's, for me, it's kind of the most difficult situation when you have something that you don't understand, and you realize that suddenly, for some chance, your VMs are slow. And when you go to the metrics and analyze those, there's an increase of latency, but there's no corresponding effect on the CPU hypervisors. It was in a recent delivery of hardware I would receive. It was, just to give more details, it's like, well, this deployment was quad servers in a 2-unit that were sharing power supplies. But then, what we learned a bit later is actually the CPU was throttled. Yeah, this is why your machines are slow. So instead of running at 275, they were running at 400 megahertz. Another thing that we found out is one of the power supplies was down, but they are redundant, right? That was not the case. And actually, we also found out that if you hard reboot the server, the CPU comes back to the nominal speed. That's odd. But also, you will say later, that triggers, if you do the reboot, it will trigger another issue. What we found out on this delivery, it was a bug in a component, it's called the CPLD. That's actually taking care of the power envelope of the quad. And in one of the power supplies, it was trying to protect the server to not be kind of burnt. And it was like capping the power distribution to the server to the limit of these 400 megahertz. It was just a bug in the CPLD firmware. The problem is we have machines there that we need to evacuate, because you need to evacuate not only one server, it's like 4, and find space to do that. What we got for free after the investigation is now we have energy metrics of every single component on that hardware. So we can also kind of tweak it ourselves. Another kind of nightmare that we were having, like in one of the, basically a late afternoon on a Friday, we we have an hypervisor crashing in a loop. And I hosted critical VMs for some of the experiments that they need to have it up and running. When you look at it at the very beginning, it was like, yeah, it's like this server is crashing, it has kernel dumps, so it's crashing more or less like every 10 minutes. And the first thing is like every single boot of volume VM that you have there, you kick it out, at least you recover partially. But then the experiments wanted the other VMs that were there that are in ephemeral drives. So as I said, late in the afternoon, we're debugging it, and basically we're like, okay, look at the start trace and points to the defective DIMM module. Okay, what we can do without going there and replace it, you just try to disable it. So we are using a kernel flag called memmap, and we're kind of basically disabling partitions on memory and try to reboot it. But no, it was no luck. It was always crashing 10 minutes later. We even ran memtest. Actually, we built the image, run memtest, test it for a while, and actually, it was like not finding any issue with memory. But we also noticed that the test that we were running, it was single-threaded. So, what do you think we did? We disabled all the CPUs, except one. Actually, it's like a setting in the values in that server model that we can do that, and basically we make the server super slow, but we're able to migrate the machines out. But we also have nightmares with these guys. So, this was like one of the longest investigations we had, that random blue screens on server machines. And the only known workaround for that, it was like to boot in safe mode. That is like very useful for users, that you have half of the stuff. The commonality, because at the end you try to find commonalities and try to see, okay, why we have all these machines in common, and they all have that they were using Windows Subsystem for Linux, or Hyper-V, virtualization flag, that we are offering to all users as part of our cloud. The funny story on that is we had enabled this flag in one of the migrations to allow the migrations to work. But actually, that allowed the migration to work. But if you reboot the server, reboot the VM, that will no longer work. Nice story. So where we ended up was all these machines that were affected, find those guys, and then like call migrate to, so change the defaults, call migrate the machines around, and they were happy after. And then it's like when we reached the, I think it was like the Yoga release. Actually, VTPM was enabled in Wallaby, but when we reached the Yoga release, we were preparing the setup for running Windows 11. We did all the basic stuff. Enabled the devices, only point the hardware to the right to the right servers, start testing, expose it to users through traits, put the minimal specs, and it was good to go. That's what we thought. Because it fight back. So we put it in production, run the OS, and then Microsoft decided in one of the updates to reduce the support the CPU families. And guess what? We had those. So we had to remove that hardware from there and actually do query updates in placement to remove those flags, those traits, because you need to undo that, and it's not easy on the APIs directly. You thought that it was the last one? Actually not. Because with the Windows 11, the updates on 2025, some of the servers give us another blue screens, set of blue screens. In this case, was a sub flag of the VMX CPU flag that was required. But this was much more complicated to enable because it was supported by QEMU, but libRSD was not supporting it. We were using at that time CPU models, tiny CPU models to facilitate migrations. We had to wait for libRSD 10.10 that brought the new flag, but it was not only, you need also these two flags that had to be enabled in NovaConf to allow these machines to boot. But it's not only Windows.
Exactly. So our little fella from time to time also give us some pains. And in a way it makes sense because all our hypervisors are Linux. We run Red Hat, Alma Linux. The vast majority of our virtual machines are running Linux as well. Either, again, Alma, Red Hat, Fedora CoreOS, in Kubernetes, OpenShift. So from time to time, we have issues with Linux as well. In general, these are, let's say, little minor nightmares. Things like with upgrades, you get kernel upgrades, QEMU. Sometimes a CPU flag will disappear, a CPU flag will appear. If you configure CPU models flag, this will have some conflicts in affecting like migrations, maybe booting sometimes. An example would be recently with AMDs, we have this flag flash by SID appearing, affecting some of this configuration because it wasn't based in host model. You will be rebooting servers, getting new kernels, new versions. But anyway, things we have under control. Same thing with libraries. We will be upgrading to minor releases of the operating system, and sometimes there are some incompatibilities between libraries. This, in general, for us, translates into problems attaching volumes, block storage, because maybe a long running VM has a long process linking to some libraries that when they try to load a new one, there are some incompatibilities. This we control, in general, with doing some rollouts in a more controlled manner or moving machines around. But sometimes, apart from these little, let's say, nightmares, things can get more complicated than that. And this is what happened when we were moving from CC7 to EL8 in 2023. And the campaign was running super smoothly. We were moving machines, as you see, the old versions were going down. We were super happy. And then we started getting some users reporting issues. My machine cannot connect to it. I lost network connectivity. I connect to the console. It's like frozen. And at the beginning, there were only reports from Windows. I thought, it's Windows again. As you see in this section, so it was not Windows. Because then later on, we have also reports from people like databases, Kafka, build nodes. Not a lot, a few cases during the weeks, but still something that we have to start taking a look to it because there is something fishy going on. And this is what we did. It was a super frustrating weeks of trying to understand. At the beginning, the only things we saw is like doing a lot of migrations of the virtual machine. We just revive like nothing happened the virtual machines. So they will continue to work just fine. So, okay, so this has to do with the virtualization, something connected with the process. We were investigating the different cases, the behaviors, to see if there is anything that matched. We just saw that the virtual CPUs were spinning 100% of the time, doing no work. And then also we have a suspicion because of the types of workloads, it's a bit memory intensive, that maybe KSM could have a role into that. We decided to disable it, sorry. And as we didn't have a lot of cases, it was difficult to say if it had a proper impact. We saw that in the case of Windows, this seemed that it helped and it reduced the cases, but still, these were months, weeks of core dumps, taking a look to the memory of the virtual machines, gathering all these cases, taking a look to every possible debugging with GDB, the processes, nothing. We opened a case with Red Hat. They were offering their help to try to investigate as well these cases. It was a tricky one. But one day, in one of our web patrols to see all the symptoms, if there is someone out there that is being affected by the same thing, we were lucky, and we found in an entry in the Proximus forum a reference to a recently fixed bug in the kernel related to a sign extension of one function that is listed there, and also the links. These links are useless because you cannot click on them, but we will make the slides available later so you can take a look and investigate. But basically, yeah, there was this function that is used for the KVM memory management unit to control all the memory of the virtual machine. And for the symptoms, it's like, yeah, this is our thing. It's like the CPU will hang when in this counter that you see there that is used to count the number of memory pages invalidations of the processes, will flip the bit 31, boom, machine gets into the symptoms we were saying. And this explains also the symptoms that we saw. It's like if you live migrate to a different hypervisor, new process, new counter, the machine is fine because this counter is then working as expected for KVM. Then also this decision that we took to disable KSM, it also implies that there are less memory merges. This means that this counter will increase more slowly. And for some cases, like in Windows, this helped. So in that regard, we were lucky. So okay, this seems that is the thing. We managed to reproduce it with some tips that were mentioned in this entry and in this forum entry, and we reported to Red Hat. I said, oh yeah, thanks a lot. We will target it for back in the day for 8.10, 9.3 releases. But these were still a few months away from our release cycle, and we didn't want to have this rate of machines stopping working because this could have an impact for databases, different things. So this was important. So we decided to think how we could avoid these issues from happening. Something that was mentioned in this post in the forum was a way to inspect this counter, this value, using eBPF. I said, could we leverage that to avoid having these issues, try to get machines at risk, at proactively live migrating? And we decided to take a look to that. So I guess you know eBPF, not going into details into that. Sandbox in the kernel, you can load some modules, some cool stuff there, and then, yeah, in our case, monitor this thing more properly. But the problem is that it was, again, a learning curve because it was the first time we were doing such a thing, writing one of these modules. We saw some frictions between, because we were developing this thing for EL8 and EL9. There's a few things that in 8 were missing. Some header files that you can generate automatically were missing. Some of the structs that we were requiring for our module. So you have to compile it in a little different way. There were some functions, helpers that are there that are called compile ones, run everywhere to make it more portable, that again, were not there, so a bit annoying. But anyway, at the end of a few weeks of work, we come up with this workflow that was working. So basically what we decided is to put a timer on the hypervisors that will inject an eBPF module in the kernel. This module will put a kprobe into the calling function of the one that had the bug. So it will be the place where this value, this counter, was coming with the right that data type. We'll be collecting that value together with the process ID of the VM, and we put it in an eBPF map that will be a structure that you can use them from user space to read data from the kernel. So with this data, we had the value of the counter, the process. Then we are using as monitoring tool collect D. So we were collecting this data, enriching the process ID with the UID of the VM, and then sending this to our central monitoring, with the idea that we could do some forecast of, okay, at this rate, what are the machines that are at risk? Because in that case, we can either proactively live migrate them or notify the users that maybe they have to hard reboot or do some actions. And actually, the results were better than expected, because for the problematic cases, the trend was so obvious that we were able to precisely estimate when the VM would fail. So in this case, we could, for the use cases that we could live migrate, we live migrate transparent for the users, nobody notices. For other more heavy workloads that we cannot easily live migrate, we could tell to the users, look, you are affected by this bug, your virtual machine is going to stop working in this amount of days, you should hard reboot it before. Do it in the moment of the day that you prefer, but this will happen. And it was nice because since we put this in place and until the kernel was fixed, no other cases happened, so we were able to work around the bug with this. So this will be one of the samples with Linux that was quite tough. Then we have networking. That for many years, it was an area that was not painful at all for us because our network is super simple. We're using Linux Bridge. We have a single network, flat network. But now we are in this migration, as Jose said, of migrating to OVN. And yeah, this new kid in town is getting us out of our comfort zone. We are in this process of the migration. You can read more about it in our tech blog. There was a presentation yesterday as well. We will share the contents. And now at the moment, we have a data center with OVN. We are migrating another data center. We are getting operational experience with it. Sometimes it's just tuning configuration that you didn't know about, but other times there are more difficult things that we are learning the hard way, that sometimes is either the best way or the only way that we were able to do it. So many of these issues is getting us out of our comfort zone. And one example, it could be this one, that as Jose said, this case of the CPU throttling, we had to at some point hard reboot hypervisors, and this triggered a different thing. So we were hard rebooting them, and some users are starting to report connectivity issues. Depending on the routes of the traffic, depending on the broadcast domain of the virtual machines. So this was weird. And we started to investigate a bit further with TCP dumps into the tunnels with all these things. The symptoms that we saw is that this traffic was broadcasted through all the segments, while it should stays in the same segment as you see. The idea is that one segment, the traffic should go through the integration bridge with the segment patch port to the external bridge and then leave the traffic, but we saw that this was going the other way. And then routers were detecting MAC duplicates. There were the EVPN discrepancies that affected routing. There were some IPv6 routes broadcasted to clients where they shouldn't happen. So this was quite tricky. The only thing we discovered is that restarting OVN controller will fix it. So we did it. We cleaned all the mess that was left behind. And then we replicate this in a control environment together with our networking team. And we started to try different things. We talked with the Neutron developers in IRC, and they said, when there is an unclean reboot, it would be nice if you clean things like the OVNDB, the chassis, and some reference to the hypervisor. We did this. No, we were still able to reproduce the issue with an unclean reboot. We also saw that in the Open vSwitch bridges, there were some interfaces left behind for the tunnels. Also, the patch ports for the segments were there. I said, OK, let's clean those ones as well after an unclean reboot. And this seemed that it was the key point to fix it. In particular, the patch port for the segment, if we remove it before starting OVN controller, etc., this traffic going through the tunnels to the wrong place wouldn't be happening. OK, so we have the workaround. How do we shape it to put it in production until we understand what is the root cause? So we decided to put all of this as a systemd unit. The systemd unit would be placed after OpenVSwitch, so we can interact with it, and then before OVN controller, before OpenStack Nova Compute, before the metadata agent. And the logic of this unit will be that it kicks at the start time, no matter if it was a clean or unclean reboot, and it will do all these operations. It will clean the information in the OpenDB related to the chassis to the hypervisor. It will clean all the interfaces that shouldn't be there in Open vSwitch. So this was our workaround. In this case, it wasn't like the previous one. We didn't understood yet what is the root cause, but we put a mitigation in place that we will avoid this issue from happening again. And with OBN, we know that the nightmares are not over yet. We have a few things there, some traffic loss here and there, some packet drops. We have to tune a few things. Sometimes the metadata port does some nasty things. So I'm pretty sure that in future summits, we will come here with more in this area. So yes, stay tuned. And before finishing, it's like, I think it's nice to share these sort of experiences, not only ours, it's nice to know about yours. There are many places where we can share all of this. There's IRC, there are different SIGs, there's a matrix channel for operators, and there are different things. And there is some proposal from for the Foundation for Open Infra to discuss this area at the next PTG about regrouping all these ops-facing activities. So I'm pretty sure your input as operators will be very welcome. So I invite you to, if you want to join that day, there is a link there, and to give your feedback about how you feel about all these things and your view as operator for the interaction. So with this, we are done. A bit tight in time maybe, but yeah. There's some links here to our tech blog. We try to be active writing about what we do. You can come to CERN and visit the facilities, or you can join us and work with us. You see, our work is quite nice and keep you busy. So thank you. Thanks a lot.
Thank you.